So here's a problem where we have a piston where this thing right here is moving back and forth and turning the wheel in this direction. And we want to find a formula for the distance between this C right here and B. So let's start in this position. We know the radius of the flywheel is 4 inches. We know that the arm is 12 inches. And I've gone ahead and put an angle in here. And once that angle's in there, I have a right triangle. And I can label the vertical side of that right triangle for sine theta. We know that from all our trig so far. And the horizontal side for cosine theta. And I'm going to call this length L. This length here, oops, it's red, but you get the idea. And again, what we're looking for is D. Find a formula for the distance between C and B. So here's the work. What I'm going to do is I'm going to look at this triangle over here. I've got the sides labeled for sine theta, 12, and L, and I can use Pythagorean's theorem to come up with this relationship here. And that allows me to solve for L. And then, if I'm looking for D, D is just 4 cosine theta plus my L. So, I know what L is. I just go ahead and plug it in, and I get this lovely formula. Now, we need to be careful because I just did that in the first quadrant. I just want to show quickly that you get the same equation no matter where the arm is in the circle. So I move the arm down at the fourth quadrant here and put my information in. And the difference with this picture is this green length is actually negative 4 sine theta because sine of theta is negative. So if you want the length to be positive, you got to put this negative in front. But that doesn't really change anything because when we do our right triangle Pythagorean theorem with this triangle over here, the negative on the 4 sine theta will get canceled. So every other part of the picture is the same, and we end up with the same equation. So let's look at the second quadrant. This time, this length has to do with cosine, but in the second quadrant, cosine is negative. So we really need to put an absolute value around it. And because cosine is negative, putting a negative in front actually makes it positive. And this time, my D is actually equal to L minus the purple length. So our formula for D is actually 4 minus the absolute value of 4 cosine theta, but of course when you subtract the absolute value, you get L plus 4 cosine theta. At the same time, we still have this relationship about L, right? This is L right here. It's the same relationship, but our right triangle is bigger than it used to be. And just to reiterate, this is L, and it comes from the big triangle here. Okay, so now that we know that we have this equation, no matter what quadrant we are in, I didn't do the third, but you can imagine that you can do something similar. We actually don't want the answer in terms of theta, we want it in terms of t. But they tell us that the flywheel rotates at 20 revolutions per second. So what we know is that the period is 1/20th second per revolution. And we do our lovely formula about how to find B, and that means that our angle is actually 40 pi t. So we have our equation in terms of t, and we're done with the problem.